So the last 2 days, we learned a little bit about what are called permutations and combinations. So now we're going to learn a little bit more about the difference between each of these, as well as the formulas and how they work. So a permutation is an arrangement where order matters. So a good example of that is finishing a race. Order matters because you would rather be first than fourth. A combination is an arrangement where order does not matter. So for example, if you're buying clothes, it does not matter which order you put them on the counter, you go home with the same clothes. All right, so in this lesson, we're going to take a look at several different examples. The first thing that we need to do is decide whether or not it's a permutation or a combination, and then we can use the formula to evaluate how many different options we have in each case. So our first example is a lock or combination. Doesn't matter which order you turn the dial for your lock or combination, or can you do it in any order as long as you hit your 3 numbers and your locker will open. Order does matter, so it actually should be called a locker permutation instead of a locker combination. This is one of my favorite examples when we get to permutations and combinations. So how many different possible permutations are there to open your locker if it has 49 numbers? Well, there's 49 numbers to choose from. It's a permutation, and we need 3 of those numbers. So if you punch this in on your calculator, finding the P button, you would get 110,544 different possible locker combinations. Now, when you use the permutation button, it assumes that once you choose an item, you can't choose it again. So this would be how many ways that you can have a locker combination with 3 different numbers. If it's a locker combination where the numbers can repeat, then we would simply use fundamental counting principle, where we have 49 numbers to choose from for the first number in our combination, 49 numbers for the second choice, and 49 numbers for the third choice. In this case, we would have 117,649 different possible locker combinations, or permutations, as the more accurate term would be. Second example, we're looking at a password. Does the order in which we type in our password matter? Yes, it does, so this would be another permutation. This one explicitly said that no letter can be repeated. Because it says we have letters, we're going to assume that our entire 5-digit password is all letters. So there are 26 letters in the alphabet, order matters, and we're choosing 5 of them for our password, which would give us 7,893,600 different possible password combinations with only 5 letters. Next example, if I'm choosing volunteers, does the order in which I choose my volunteers matter? This would be a combination, because depending on the job, if I need all 3 of them to do the same thing, the order in which I choose them doesn't matter. So we have 20 students in the class, and we are choosing 3 of them to volunteer for me. This would give us 1,140 different ways that I could choose 3 volunteers from a class of 20. And our final example, does the order in which we choose our pizza toppings matter? No, it doesn't. We end up with the same 3 toppings, so this would be a combination. So there are 9, and we're choosing 3 of the toppings. So that would give us a total of 84 different ways that we could top our pizza. And finally, here's your U-Try question.